In today's video, we are still working on proving triangles congruent. We're on to part 2. We're going to start with postulate 21, angle side angle, which says if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So let me illustrate this concept. Let's say that we have triangle XTR and MJN. So we're talking about, let's say that angle T and angle J are congruent. Let's say that angle X and angle M are congruent. And then the sides that are in between those corresponding angles are congruent. That's an illustration of the angle side angle postulate. Let's move on. Another postulate we can use, angle, angle, side. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So for instance, let's label these two triangles MLO and PRT. So we're looking at two angles in a row, two consecutive angles being congruent. So for instance, angle L and R and angle O and T. And then a side on the outside of, not between those two angles, but one of the other two sides. So for instance, PT and MO. This demonstrates angle, angle, side, angle, angle, side. All right, so that's what that looks like. Let's move on. I'm giving you some triangles here, and we want to know if the triangles are congruent, and if so, why. Well, let's take a look at this first one. In this diagram, we have two angles congruent. We have two sides congruent. Now, look at these two angles. These are vertical angles, so those are also congruent. I'm going to use a different color to demonstrate that. And look at that, we have angle, side, angle, angle, side, angle. So that's the postulate that we're using. And let's write a congruent statement. So it looks like triangle VTQ is congruent to triangle KTM. Moving on to this next diagram. We have basically a parallelogram with a diagonal. We've got opposite sides parallel. And let's see what we know about this. Well, opposite sides, if two lines that are parallel are cut by a transversal, we know that alternate interior angles are congruent. So we know angle STR and angle URS are congruent. But it's also the same going the other way. We know that since RS and UT are parallel and they're cut by this transversal, that their alternate interior angles are congruent. So angle RTU is also congruent to angle SRT. Now the other thing that we know is that these triangles share a side. So that side is congruent to itself. So it looks like we have angle, side, angle, angle, side, angle. So that's the postulate that we can use. And now we have our congruent statement. So we want to say that triangle RST is congruent to triangle TUR. Let's move on. We have that BD is perpendicular to AC. So if that's the case, we know that that angle BDC and angle ADB are right angles. So those are congruent. And we're also given that AD is congruent to DC. We'll also notice that they share a common side. So BD is congruent to BD. Now this is going back to one of the postulates we used in our last lesson. Notice now we have side, angle, side, side, angle, side. So that's what we're using to prove the triangles are congruent. And we can say that triangle ADB is congruent to triangle CDB. Now let's take a look at this one. We are given that UJ and RT are parallel. So if they're parallel, we know that their alternate interior angles are congruent. Okay, notice that they are cut by two transversals. So also the other alternate interior angles are congruent. And we also know that vertical angles are congruent. So look at this. But wait a minute, all this tells us that, that three angles are congruent. We also need a side in there to show that these triangles are congruent, and we don't know anything about the sides. So we're just going to have to say that there is not enough information. Let's move on. We're going to use some of the postulates we've learned to write some two-column proofs. You are given in this diagram that AD is parallel to EC. We're also given that BD is congruent to BC. And we're going to list statements and reasons, starting with our given information. So we're going to write the AD is parallel to EC, and that is given. We also know that BD is congruent to BC, and that's given. Well, if the lines, if AD and CE are parallel, and notice they are cut by a transversal, we do know the alternate interior angles are congruent. So we know, for example, that angle D and angle C are congruent to one another. So let's write that down. Say angle ADB is congruent to angle ECB, and that's because of the alternate interior angles postulate. We'll just abbreviate that. And let's see what else we know. We also know that since those lines are parallel and they're cut by another transversal, we know that angle A and angle E are congruent. So if we really want to be formal with that, we'll say angle DAB is congruent to angle CEB. And that's also by the alternate interior angles postulate. And now notice we have an angle, and a side. Angle, I'm sorry, going the wrong way. Angle, angle, and side. So that is enough to prove that our triangles are congruent. So triangle ABD is congruent to triangle EBC. And that will be by angle, angle, side. Let's move on. It says indicate the third congruence required to prove the triangle is congruent by the given method. We want to prove that triangle ABC, which we'll label, is congruent to triangle DEF. Now, it says that we are given that angle B is congruent to angle, this should say angle E, by the way. That was a typo. So angle B is congruent to angle E. That a segment AB is congruent to segment DE. And it's asked you to use AAS. So what's the third one that we need? Well, we need two angles in a row, and the side can't be between the two angles. The congruent side can't be between the two angles. So that means what we need is that angle C must be congruent to angle F in order to use the AAS postulate. Let's move on. Let's label these triangles. Alright, so we're given the information that angle C is congruent to angle F, and that angle A is congruent to angle D. And we're asked to use ASA to prove that these triangles are congruent. Well, in order to use ASA, we must pick a side that's between the two congruent corresponding angles. Well, that would have to be side AC and side DF. Those are our only choices. So we would also need to know that AC, side AC was congruent to side DF in order to use ASA. Let's move on. We have a two-column proof here. We are given that angle DBC is congruent to angle ACB, so let's write that down. So DBC is congruent to ACB. We'll mark that. We're also given that angle A is congruent to angle D. And we would like to prove that triangle ABC is congruent to triangle DCB. So let's write out the statements and the reasons. Let's start with the given information. Angle DBC is congruent to angle ACB, and that is given. Number two, we know that angle A is congruent to angle D. That is also given. Third thing that we know that both triangles share the side BC. So BC is congruent to BC, so we can just mark that. I'm going to use two lines to mark that. And anything congruent to itself, that uses the reflexive property. So now let's see what we have. In each triangle we have an angle, and a side, an angle, and a side. So that's enough to prove that the triangles are congruent. So triangle ABC is congruent to triangle DCB by angle, side. That's it for today. Thank you.